Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 4.2, Applications, Problem 2. This is Section 4.2, Applications, Problem 2. It says the Cut-Right Cutlery Company sells 3 different cutlery sets: the basic cutlery set, the regular cutlery set, and the deluxe cutlery set. The basic cutlery set consists of 2 utility knives and 1 chef's knife. The regular cutlery set consists of 2 utility knives, 1 chef's knife, and 1 slicer. And the deluxe cutlery set consists of 3 utility knives, 1 chef's knife, and 1 slicer. The profit on the basic cutlery set is $30. The profit on the regular cutlery set is $40. And the profit on the deluxe cutlery set is $60. The company has 800 utility knives, 400 chef's knives, and 200 slicers. How many of each cutlery set should they make in order to maximize their profit, and what is the maximum profit? So this is a problem that we have to set up as part of a 4-step process. First, we have to identify our variables, then write out our object function, set up our constraints, and then finally write that each variable is greater than or equal to 0. So the first step of those 4 steps is identify your variables. It's the things being made. Now there could be some confusion on this. Are they making the knives? It's really the cutlery sets that they're putting together from the available knives. So X1 will be the basic cutlery set. And we don't have to write out cutlery set. They're all types of cutlery sets. So I just put basic. X2, the next type is the regular cutlery set. And again, we can just write regular. And then X3, the third one, is the deluxe. So of the 4 steps, that's step 1. I have identified my variables. These are the 3 things that are being made that are generating profit for this particular problem. So step 2 is write the object function, which involves looking for information that's usually about profit, usually near the end. Again, this problem is reasonably typical. Near the end of it, or starting about halfway through, you can find the information about profit. So in terms of the object function, we're going to write maximize z equals, and now when I go back to the problem and I find the part where they start talking about function, it says the profit on the basic cutlery set, that's X1, is $30. So 30 X1. And then the profit on the regular cutlery set is $40, and the regular cutlery set is X2. So 40 X2. And then finally it says, and the profit on the deluxe cutlery set is $60. And the deluxe one is X3. So plus 60 X3. So in terms of step 2, write out the object function. The result of that step 2 is maximize z equals 30x1 plus 40x2 plus 60x3. That's what we want to maximize. And step 3 is write out the constraints. So we'll have subject to. And now what's going to limit how many of each type of set we can assemble is how many of the different knives are available. So altogether, the company has 800 utility knives, 400 chef's knives, and 200 slicers. That's what's going to determine how many of each type of set can be made. So we're going to have one constraint for the 800 utility knives. So I'll write here 800, and I'll put utility. You don't have to put knives, they're all types of knives. 400 chef's knives. So under that I'll put 400 chef. And 200 slicers. And I'll label it like that. Again, each constraint will have an inequality symbol of less than or equal to. Again, chef's knives, for example, if you have 400, you can use up all 400 or 372 or 399, but you can't use, say, 402 of them because you just don't have it. You can use all 400 or a little less. And the same thing for the utility, the slices. They all have to be less than or equal to. Now, I have to go through and write out how many of each type of knife is used up by each type of cutlery set. So we start from pretty much the second sentence of the whole paragraph here. The basic cutlery set consists of 2 utility knives and 1 chef's knife. So 2 utility knives, and the basic set rather is X1. So 2 X1 for the utility knives and 1 X1 for the chef's knives. Now the basic set doesn't have any slicers, so I'm not going to put anything for that. So again, the basic set, which is X1, has 2 utility knives and 1 chef's knife. And that's it for the basic set. And so I'll put plus, and now we do the regular set. So I go to the next sentence in the whole paragraph that explains the problem. The regular cutlery set consists of 2 utility knives, 1 chef's knife, and 1 slicer. So going back to my inequalities here, the X2, which is the regular set, contains 2 utility knives, 2X2, 1 chef's knife, so 1X2, and 1 slicer. So again, the regular cutlery set is X2. Each regular cutlery set has 2 utility knives, 1 chef's knife, and 1 slicer. So those will all get a plus. And now finally the deluxe set, the fanciest one, it has 3 utility knives, 1 chef's knife, and 1 slicer. So for the X3, which is deluxe, 3X3 for the utility knives, and again 1 X3 for the chef's knife, 1 X3 for the slicer. So again, deluxe set is X3. Each deluxe set has 3 utility knives, 1 chef's knife, 1 slicer. So that's step 3, set up the constraints. And the final step is for each variable that you use, you have to mention specifically that it is greater than or equal to 0. So we have 3 variables, each one is greater than or equal to 0. Now it's set up. Next we have to solve it. So again, because of the fact that there are 3 variables here, we have to use a simplex tableau. We cannot really graph the feasible region, label corner points. If it was X1 and X2, we could, but X1, X2, X3, we have to use a matrix. So in order to turn the problem that we have set up on the board here into a matrix, we have to convert the inequality symbols we have into equal signs and rearrange the variables in the object function. And that will allow us to make a matrix, or our initial simplex tableau. So the first inequality symbol or constraint coming from the utility knife constraint, 2x1 plus 2x2 plus 3x3 is less than or equal to 800, is going to become 2x1 plus 2x2 plus 3x3 plus S1, and I'm going to leave a little bit of a space, and then equals 800 instead of less than or equal to. So now I've made one of 4 equations that I'm going to make. The next constraint about the chef's knife is going to generate my next equation. So the chef knife constraint right now is 1x1 plus 1x2 plus 1x3 is less than or equal to 400. I'm going to write that as 1x1 plus 1x2 plus 1x3 plus S2, a different slack variable. Again, I'm not going to line it up with the S1 that's in the equation above it. I'm going to kick that off to the side a little bit. And now instead of less than or equal to 400, it's going to be equals 400. And the last constraint about the slicers right now is 1x2 plus 1x3 is less than or equal to 200. I'm going to write 1x2 plus 1x3 plus S3, yet a different slack, is now equal to 200. And I make sure the x2s line up and the x3s line up as I write my equations one over the other, because eventually those are going to represent rows in a matrix. The inequalities with the greater than or equal to zeros do not have to go into the tableau or the matrix, but the object function does. As the problem is originally written, it says maximize z equals 30x1 plus 40x2 plus 60x3. So that object function is an equation already. It doesn't need a slack, but I have to rearrange the x's so that they're on the left side of the equal sign, so they'll line up with the x's in the other equations that I'm using. So now the 30x1, which starts on the right-hand side the way the object function is originally written, I'll move it to the left and it'll become negative 30x1. And then the 40x2, which is the next part of my object function, is going to move to the left side of the equal sign. It'll become negative 40x2. And the last part of the object function is 60x3. Again, it starts on the right. I need it to be on the left, so I'm going to move it to the left. It'll become negative 60x3. I don't need a slack because the object function starts as an equation, but I do have to account for the object variable, which is the z. So I'll put that in my equation. Equals, and after I've moved all the parts of the object function to the left side of the equal sign, on the right side, I would have a 0. Now, at this point, every part of the problem I started with is written as an equation, and the equations are written so that all the variables line up. So underneath the equations that I have written, I'm going to start my initial simplex tableau. I have enough room to write one tableau here, then we'll move off to the right a little bit. So as I set up my column headings, I'm going to have an x1 column, an x2 column, an x3 column, an S1 column, an S2 column, an S3 column, a Z column, and an RHS for right-hand side column. So the top equation that I wrote out previously is going to become the top row of my matrix. So the equation was 2x1 plus 2x2 plus 3x3 plus s1 equals 800. So as I set that up as an initial simplex tableau, the x1 position will be 2, the x2 position will also be 2, the x3 position will be 3, the s1 position will be 1, the S2 position will be a 0. S3 will also be a 0 on the top row. The Z position will be a 0 on the top row. And the right-hand side value will be 800. Now the second row of my matrix is going to come from the second equation that I had written. The second equation was 1x1 plus 1x2 plus 1x3 plus S2 equals 400. So as I write the second row of my matrix, the x1 position will be a 1. The x2 position will also be a 1. The x3 position is yet another 1. The s1 position in the second row will be a 0. The s2 position will be a 1. The s3 position will be a 0. The z position will be a 0. And the right-hand side value will be 400. Now the third equation that I wrote will become the third row of my matrix. The third equation was 1x2 plus 1x3 plus S3 equals 200. So now as I fill in the third row of my matrix in the x1 column, since there is no x1 in my third equation, the x1 position has to be a 0. I can't leave a blank spot in the matrix. The x2 position will be a 1. The x3 position will be a 1. The S1 position will be a 0, S2 will be a 0, S3 will be a 1, Z will be a 0, and the right-hand side value will be 200. And finally, the bottom row of the matrix, what we have is the equation negative 30x1 minus 40x2 minus 60x3 plus Z equals 0. So as I make that a row of my initial simplex tableau, the x1 position will be negative 30. Don't forget the negative. The x2 position will be negative 40. The x3 position will be negative 60. The S1 position will be 0. S2 will also be 0, and so will S3. There were no slack. The Z position will be 1, and the right-hand side value will be 0. So now I have the initial simplex tableau. A lot of negatives in the bottom row. What we're going to have to do is find the pivot point, pivot this matrix, see if it has to be pivoted again or not. So let's find the pivot. You find the pivot element by finding the most negative value in the bottom row. So in my bottom row of that initial simplex tableau, I have negative 30, negative 40, and negative 60. Those are the negative values in the bottom row. Negative 60 is the most negative. That negative 60 appears in my X3 column, so the X3 column is the pivot column. So in the X3 column, there's a 3 in the top position, a 1 below that, another 1 below that, and the negative 60 in the bottom. So the pivot cannot be the negative 60. Pivots can never be negative. So it's either the 3 in the top or one of the ones below it. Which one is it? What we're going to do is examine our ratios of right-hand side value over pivot column value for the X3 column, find the smallest positive ratio. So now, in the top row, that ratio of right-hand side value over pivot column value will be 800 for right-hand side value over 3 for pivot column value. So that's going to be 266.666666. So put 266. I'll just round it to 7. That's close enough. In the second row, the ratio of right-hand side value over pivot column value is 400 for right-hand side value over pivot column value is 1. 400 over 1 reduces pretty nicely to 400. And finally, in the third row of our initial simplex tableau, the ratio of right-hand side value over pivot column value is 200 for right-hand side over 1 for pivot column. 200 over 1 reduces to 200. So my 3 possible ratios are 266 point something, 400, or 200. So I want the smallest positive ratio. Well, of 266, 400, or 200, 200 is the smallest number. That 200 came from the ratio that I got in the third row. So in the third row of my X3 column is a 1. So that 1 in the third row down of the X3 column is the pivot for this initial tableau. Now to pivot a matrix, what you have to do is turn the pivot element into a 1. Fortunately, it already is a 1. That'll save us some work. And then zero out all the other positions in that column. So the next tableau we make, I'm going to start making zeros in that X3 column. I already have the 1. So let me set up the next tableau. Let's see. We'll go to a different color. Again, just to keep them clear, which is which. So let me set up some more column headings because I'm down to the bottom of the board on this. I have to set up the columns again. So we had an X1 column, an X2 column, an X3 column, an S1 column, S2, S3, Z, and RHS for right-hand side. So I'm going to want to make a new top row in which the 3 in the top position of the X3 column becomes a 0. So I'm working in the top row of row 1. So next to row 1, I'm going to write a little equation that will be row 1 equals some stuff plus the old row 1. Again, that equation begins with row 1 because that's the row where I need to make a 0. The equation ends with row 1 because it should begin and end at the same row. I left the space in the middle that I called stuff. The stuff is going to be the row with the pivot position, which at this step is row 3, and it's going to be multiplied times the same number but opposite sign as what's becoming a 0. What's becoming a 0 is a positive 3. So same number opposite sign is negative 3. So that means the equation that I'll use to make my new row 1 is row 1 equals negative 3 times row 3 plus the old row 1. I'm going to use that equation to generate a whole new row 1. So in the X1 column, negative 3 times row 3 is negative 3 times 0, which is 0, plus row 1. So I'm going to add 0 plus 2. 0 plus 2 is 2. So next in the X2 position, negative 3 times row 1 is negative 3 times 1, which is negative 3. You're going to add that to row 1. So you're going to add negative 3 and positive 2. Negative 3 plus positive 2 is minus 1. The X3 position, you're going to do negative 3 times row 3 is negative 3 times 1, which is negative 3. You're going to add that result to row 1. So I'm going to add negative 3 plus positive 3 is 0. And then the next is the S1 column. Negative 3 times row 3 is negative 3 times 0. that result to 0. You're going to add the result to row 1, so you're going to add 0 plus 1. 0 plus 1 is 1. Now next the S2 column, you're going to do negative 3 times row 3 is negative 3 times 0. That result is 0. You're going to add that to what's in row 1. So you're going to add 0 plus another 0, which gives you 0. And then next is the S3 column. You're going to multiply negative 3 times row 3, which is negative 3 times 1. That result is negative 3. You're going to add that to row 1. So you're going to add negative 3 plus 0. Negative 3 plus 0 is negative 3. Next column is the Z column. Negative 3 times row 3 is negative 3 times 0. Negative 3 times 0 is 0. Then you're going to add that result to row 1. So you're going to add 0 plus another 0 is 0. And finally, the RHS column, negative 3 times row 1 is negative 3 times 200. That's negative 600. You're going to take that result, add it to row 1. So you're going to have negative 600 plus positive 800 is 200. So that completes the top row. I made the 0 where it goes. So now in row 2, I need to make a 0 in the x3 column to continue with the pivoting process. So row 2 in the x3 column right now is a positive 1. It has to become a 0. So next to row 2 in the tableau that I'm working on now, I'm going to write one of those little equations. It's going to say row 2 equals some stuff plus the old row 2. Again, my equation begins with row 2 because that's the row making the 0 in row 2. The equation ends in row 2 because it should begin and end in the same row. Now what I refer to as stuff is the row with the pivot position, which at this step is in row 3. It's going to be multiplied times same number opposite sign. It's what's becoming a 0. What's becoming a 0 is a positive 1. So same number opposite sign is a negative 1. So the equation I'm going to use to make my new row 2 is row 2 equals negative 1 times row 3 plus the old row 2. So now I just have to do that to every position. In the x1 column, negative 1 times row 3 is negative 1 times 0. That's 0. Add that result to row 2. So you're going to add 0 plus 1 is 1. Next column, negative 1 times row 3 is negative 1 times 1, which is minus 1. You're going to add that result to row 2. So you're going to add minus 1 and positive 1, which gives you a 0. The next position is the x3 position. So you're going to do negative 1 times row 3 is negative 1 times 1. That gives you a minus 1. You're going to add that result to row 2. So you're going to add negative 1 plus positive 1 is 0. The next column is S1. So for S1, negative 1 times row 3 is negative 1 times 0. That's 0. You're going to add that to what's in row 2. So you're going to add 0 plus another 0, which is 0. The next column is the S2 column. You're going to do negative 1 times row 3 is negative 1 times 0. That gives you a 0. You're going to add that result to row 2, so you're going to add 0 plus 1, which is 1. The next column over is the S3 column. So you're going to do negative 1 times row 3 is negative 1 times positive 1. It's minus 1. You're going to add that result to row 2, so you're going to add minus 1 plus 0 is minus 1. The next column is the Z column. So again, you're going to do negative 1 times row 3 is negative 1 times 0. That's 0. Plus row 2. So you're going to add the 0 plus another 0 that's in row 2. So that gives me a 0. And finally, the last column, the RHS column, negative 1 times row 3 is negative 1 times 200. That gives you a result of negative 200. You're going to add that result to what's in row 2. So you're going to add the negative 200 plus positive 400. So negative 200, positive 400 is 200. So that completes the second row of my tableau. Now going down to the third row in my x3 column that I'm pivoting, I have a 1, and I want it to stay a 1. So I'm not going to change the x3, the row 3 at all. So for the next tableau, row 3 is going to be exactly the same as the row 3 in the previous tableau. So in x1 it'll stay 0, in x2 it'll stay 1, x3 it stays 1, s1 it stays 0, s2 stays 0, s3 stays 1, z stays 0, and right hand side stays 200. Now the bottom row is the next row of the tableau I'm working on. So again, in the bottom row of the X3 column, which is the pivot column, I have a negative 60 right now. It needs to be turned into a 0. So that's in row 4. The bottom row is row 4 for this matrix. So next to the row 4 of the tableau I'm currently working, I'm going to put an equation, row 4 equals some stuff plus the old row 4. So again, my equation begins with row 4 because that's the row I need to make the 0 in. The equation ends in row 4 because it should begin and end with the same row. And I left a blank spot in the middle that I just said stuff. The stuff is the row with the pivot position, which is row 3 for this problem I'm working on now. And it's going to be multiplied times the same number but opposite sign as what's being turned into a 0. What's being turned into a 0 is a negative 60. Same number opposite sign is positive 60. So the equation I'm going to use to make my new row 4 is row 4 equals 60 times row 3 plus row 4. And again, I'm going to do that to every position and hopefully eliminate my negatives. But as I look at the tableau I'm pulling from, I'm still going to have a negative. Right off the first thing, the X1 column, positive 60 times row 3 is positive 60 times 0. That's 0. You're going to add that 0 to what's in row 4. You're going to add 0 and negative 30. 0 plus negative 30 is negative 30. So right away I see that I still have a negative in the bottom row. And the reason why I think that's bad is telling me I'm going to have to pivot again. And it's a big matrix, but there's nothing you can do. So we'll pivot again. We'll finish this pivot and we'll find the next one. So the next column is the X2 column. 60 times row 2 is 60 times 1, which is 60. You're going to add that to what's in row 4. So you're going to add 60 plus negative 40. 60 plus negative 40 is positive 20. And the next column over is the X3 column. 60 times row 3 is 60 times 1, which is 60. You're going to add that to row 4, so you're going to add 60 and negative 60, which is 0. And next is the S1 column. So 60 times row 3 is 60 times 0. That's 0. You can add that result to row 4, which is another 0. So yeah, 0 plus 0 gives you a 0. Same thing's going to happen in the S2 column. You're going to do 60 times row 3 is 60 times 0. That gives you a 0. You're going to add that result to row 4, so you're going to add 0 plus another 0. 0 again. In the S3 column, 60 times row 3 is 60 times 1, which is 60. You're going to add that result to what's in row 4, so you're going to add 60 plus 0. 60 plus 0 is 60. In the Z column, 60 times row 3 is 60 times 0, which is 0. You're going to add that 0 to what's in row 4, so you're going to add 0 plus 1 is 1. And now I'm going to do 60 times, for the RHS column, 60 times 200 should be 12,000. Make sure I have that figured out right. So 60 times 200 is sure enough 12,000. So you're going to add that result to row 4. So you're going to add 12,000 plus 0. Well, 12,000 plus 0 is 12,000. Now, I'm not done. Because of the fact that I still have a negative in the bottom row, I need to pivot again. So that negative is in the X1 column. That's going to be my pivot column. So what's happened is I've gone from an output or profit of 0 to an output or profit of $12,000. But because I can pivot again, that's telling me that I can increase the 12,000. I can make even more money. So let me pivot this again. And again, I'm going to go to a different color just to keep the pivot very clear. So when I pivot again, first I need to find the pivot. So you find the pivot by first finding the pivot column by finding the most negative value in the bottom row. Now in this case, there's only one negative value in the bottom row. It's in the bottom of the X1 column. So the X1 column has to be the pivot column. There's only one negative. There's no question it's in the X1 column. Now the X1 column has a 2 in the top position, a 1 below that, a 0 below that, and a negative 30 below that. Now, keeping in mind that the pivot can never be negative and can never be 0, the pivot either has to be the 2 in the top position of the x1 column or the 1 in the second position down of the x1 column. It can't be the 0 that's in the third position. It can't be the negative 30 that's in the bottom. So it's either the 2 or the 1. Now, which one is it? What I'm going to do is evaluate my ratio of right-hand side value over pivot column value and find the smallest positive ratio. So in the top row of this tableau, the right-hand side value is 200 over the pivot column value is 2, the top row. So 200 over 2 reduces to 100. In the second row, the RHS value is 200 over the pivot column value is 1 for the second row. 200 over 1 is 200. And again, the pivot cannot be in the third row because the third row has a 0 in the x1 column. The pivot can't be in the fourth row because the fourth row has a negative value in the x1 column. So my two possible ratios are 100 or 200, and I want the smaller of those two values. 100 is smaller than 200. The 100 came from the ratio of the top row of 200 over 2. So my new pivot element is the 2 that's in the top row of the x1 column. So in order to pivot that 2 must first be turned into a 1, then the rest of the x1 column has to be zeroed out. Now, if we're just solving a matrix, because there's a 1 in the same column, you could swap row 1 and row 2. But because we're actually solving an initial simplex tableau, or using the simplex method, you can't just swap the rows. That 2 turns into a 1 by multiplying the whole top row by 1 over 2, which will make some fractions nothing awful. So let's set up the next tableau. So I'm going to make a line. Again, I'm going to keep changing colors for every next tableau. So the first thing I need to do is take the 2 that's in the top row of the x1 column and turn it into a 1. So in order to accomplish that, I'm just going to write a little equation next to row 1. I'm going to put row 1 equals 1 over 2 times all of row 1. Again, to make a 1, I just multiply times a fraction. To make zeros, I add different rows together to zero stuff out. So 1 over 2 times row 1, as I go through all of row 1 and multiply times a half, the x1 column, 1 over 2 times 2 is 2 over 2, which is 1. The x2 column, 1 over 2 times negative 1 is negative 1 over 2, or minus a half. In the x3 column, 1 over 2 times 0 is 0. In the s1 column, 1 over 2 times 1 is 1 over 2, or just simply a half. In the s2 column, 1 over 2 times 0 is 0. In the S3 column, 1 over 2 times negative 3 is negative 3 over 2, or negative 3 halves, or negative 1 1/2, or negative 1.5. However you like to write, I'll write negative 1 1/2. You could write it any one of those ways. Finally, in the Z column, 1 over 2 times 0 is 0. And finally, in the RHS column, 1 over 2 times 200 is 200 over 2, which I can reduce to 100. Now I've made the 1 in my pivot column, so the other rows for this tableau are not going to change from the previous tableau. So for the second row of this tableau, it's going to stay the way it is. In the x1 column I have a 1, the x2 column I have a 0, the x3 column I have another 0, the s1 column I have a 0, s2 column has a 1, s3 column has a negative 1, z column has a 0, RHS column has a 200. And then the third row of my current tableau also won't change. The x1 value will stay at 0. The s2 stays 0. S3 stays 1. Z stays 0. And the RHS value stays 200. And also for the current tableau, row 4 will stay the same, no change. The x1 value is at negative 30, which will eventually be zeroed out on the next step. But for now, it stays negative 30. The x2 value is positive 20. The x3 value is 0. The s1 value is 0. S2 value is also 0. S3 is 60. The z value is 1. And the RHS value is 12,000. Now, what I have to do to finish pivoting my x1 column is turn everything else in the x1 column, in other words, the second, third, and fourth positions, into zeros. So in the x1 column or pivot column, in row 1 is the pivot value itself, the 1. So I don't want to change row 1. So going from the tableau I have written now into the next tableau, row 1 isn't going to change at all. So the x1 value is 1. The x2 value is -1/2. The x3 value is 0. The x4 value is 1/2. The that was the S1 value is 1/2. The S2 value is 0. The S3 value will stay -1.5. The Z value is 0, and the RHS value is 100. Now, row 2 will change. Row 2 in the x1 column or pivot column is a 1. It will become a 0. So in row 2, I'm making a 0. So I'm going to write a little equation next to the row 2 of the tableau I'm working on. That little equation will be row 2 equals some stuff plus the old row 2. Now my equation begins with row 2 because that's the row I'm making the 0 in. The equation ends in row 2 because it should begin with and end with the same row. Now what I call the stuff is the row with the pivot position, which at this step is row 1, and it's going to be multiplied times the same number but opposite sign as what's becoming a 0. What's becoming a 0 is a positive 1, so same number opposite sign is a -1. So the equation I'm going to use for my new row 2 is row 2 equals -1 times row 1 plus row 2. I'm going to do that to every position in row 2. So in the x1 column, -1 times row 1 is -1 times 1. That gives me a -1. Add that result to row 2. So I'm going to add -1 and +1 is 0. Next column is the x2 column. -1 times row 1 is -1 times -1/2. That's going to be +1/2, right? The negative times negative cancels. You're going to add that result of +1/2 to what's in row 2. So you're going to add +1/2 plus 0, which is +1/2. The next column is the x3 column. You're going to do -1 times row 1 is -1 times 0. That gives you a 0. You're going to add that to row 2. So you're going to add 0 plus another 0. So that's 0. In the S1 column, -1 times row 1 is -1 times 1/2, which is -1/2. You're going to add that -1/2 to what's in row 2. So you're going to add -1/2 plus 0, which is -1/2. The next column is the S2 column. So you're going to do -1 times row 1 is -1 times 0. You're going to add that 0 to what's in row 2. You're going to add 0 plus 1. So that gives me a 1. The next column is the S3 column. So -1 times row 1 is -1 times -1.5. So it's going to be +1.5. Again, the negatives cancel. So you're going to take that +1.5, add it to what's in row 2. So +1.5 plus -1 is going to give me +1/2. Next is the Z column. -1 times row 1 is -1 times 0, which gives me a 0. Then you're going to add that to what's in row 2. So you're going to add 0 plus another 0, which is 0. And then finally, the RHS column, -1 times row 1 is -1 times 100. That's -100. You're going to add that result to what's in row 2. So you're going to add -100 plus +200. So that's 100, +100. So that completes row 2 of my tableau. Row 3, fortunately, already has a 0 in the x1 column or the pivot column. So I don't have to change anything on row 3. So moving into the tableau that I'm finishing now, row 3 will stay the same. The x1 value is 0. The x2 value is 1. The x3 value is 1. The s1 value is 0. The s2 value is 0. The s3 value is 1. The Z value is 0, and the RHS value is 200. So that one goes very easily, row 3. Now, row 4, to complete my pivot. The value in the bottom of the x1 column or pivot column is a -30. It has to become a 0 to do the pivot. So I'm going to write an equation next to row 4 of the row I'm working in for the tableau I'm working in right now. So I'm going to do row 4 equals some stuff plus the old row 4. Now, my equation begins with row 4 because that's the row I need to make the 0 in. The equation ends in row 4 because it should begin with and end with the same row. Now, what I left a blank area for and referred to as stuff is the row at the pivot position, which in this step is row 1. and it's going to be multiplied times the same number but opposite sign as what's becoming a 0. What's becoming a 0 is a negative 30, same number opposite sign is a positive 30. So the equation I'm going to use to make my new row 4 is row 4 equals 30 times row 1 plus the old row 4. Now as I do that, the x1 column, 30 times row 1 is 30 times 1. That gives me a 30. Add that result to row 4. So positive 30 and negative 30 is 0. That's good. Now this next one is really, well, I could have trouble in a couple of spots. This is one of them. So 30 times row 1 is 30 times negative a half. So 30 times negative a half is negative 15. You're going to add that negative 15 to what's in row 4. So I'm going to add negative 15 plus positive 20. That's positive 5. I don't want to see any negatives in my bottom row if possible. So next one is no problem. The x3 column, I'm going to do 30 times row 1 is 30 times 0. That gives me a 0. And I'm going to add that result to what's in row 4, which is another 0. So I add 0 plus 0, and I get a 0. The next column is the S1 column. So I'm going to do 30 times row 1 is 30 times a half. That's 15, positive 15. I'm going to add that result to what's in row 4. So I'm going to add 15 plus 0. That's 15. That's good. The next column is S2. So I'm going to do 15 times row 1 is 15 times 0, which is 0. I'm going to add that result to row 4. So I'm going to add 0 plus 0. That's 0. Now the next column is the only one that could possibly give me some trouble. So negative 30 times row 1 is negative 30 times 1.5. That's negative 45. And I'm going to add that negative 45 to what's in row 4. So it's negative 45 plus positive 60. So fortunately it's positive. It's positive 15. And now the next column is the Z column. So I'm going to do 30 times row 1 is 30 times 0. That gives me a 0. I'm going to add that result to row 4. So I'm going to add 0 plus 1, which is 1. And now I'm going to do finally the RHS column. 30 times 100 is 3,000. And I'm going to take that result of 3,000, add it to what's in row 4. So I'm going to add 3,000 plus 12,000 is 15,000. Now when I look at the bottom row, very happy to see no negatives. Not in the bottom. There are some negatives in other places, but there are no negatives in the bottom, which means there's no pivoting left to do. So I found the maximum. So we went from the first tableau or initial tableau of a profit of 0. After one pivot, we pushed the profit from 0 up to 12,000. And then by pivoting again, we went from a profit of 12,000 to a profit of 15,000. And I can see that the profit cannot get any bigger. 15,000 is as big as it can get. So now in terms of stating our solution, we can say maximum profit of $15,000 by making. So now, by making how many of each type of set? So the X1 column was the basic cutlery set. Now as I look at my final tableau, the X1 column does have a special column of all zeros and a single one in the final tableau. So that means X1 has a non-zero value. So the height of the one in that special column is in the top position. So as I go to the far right column in the top position, the same height as the one, I have a 100. So what that's telling me is I'm going to have to make 100 basic cutlery sets . Now the next column is the X2 column, and as I look in my final tableau, the X2 column does not have a special column of all zeros and a single one. So I'm not going to make any X2s, and X2 represented the regular cutlery sets, so I'm not going to make any regular cutlery sets. So I'll say no regular cutlery sets And X3 represents the deluxe cutlery sets, and as I look at the X3 column of my final tableau, I do have a special column of all zeros in a single one. So X3, or the number of deluxe cutlery sets, has a non-zero value. So to figure out what it is, look at the height of the 1 in that special column in the X3 column. The height of the 1 is 1 up from the bottom. So as I go to the far right column, or RHS column, at that height of 1 up from the bottom, I have a value of 200. So the value of X3 is 200, which means the number of deluxe cutlery sets that need to be made is 200. So I'll put 200 deluxe cutlery sets. So the final answer, you can make a maximum profit of $15,000 by making 100 basic cutlery sets, no regular cutlery sets, and 200 deluxe cutlery sets.